This is a 15-question mini-test. You can stop the video and try it first before you see the answer if you don't mind. The first question is, which of the following is the weakest electrolyte? Strong electrolytes dissociate almost 100% in water and conduct electricity. Let's start with ammonium chloride dissociating nearly 100% into ammonium cation and chloride anion. It is a strong electrolyte. Choice C. Hydrogen iodide is a strong acid that dissociates almost 100%. Therefore, it is a strong electrolyte. Choice D. Potassium hydroxide is a strong base that dissociates close to 100% and is a strong electrolyte that conducts electricity in the water. What about choice B? Hydrogen peroxide is a weak acid dissociating less than 1% in water. Therefore, the answer is B. Question 2. The image formed by a concave lens is always virtual because a concave lens diverges light. Therefore, it forms a virtual erect image on the same side of the object. Since the light spreads out, the image appears smaller than the object. Therefore, it is diminished. Choice C is the answer. Question 3. The following are two galvanic cell half reactions. If you look at the top half reaction, copper gets oxidized, giving up 2 electrons. In the bottom half reaction, silver is reduced. It gains 1 electron. Now, look at the overall reaction. Copper is oxidized, and silver gets reduced. Therefore, we don't change any sign of the half reaction voltages. We simply add the voltage values of the two half reactions. Negative 0.34 volts plus 0.80 volts is equal to 0.46 volts. And the answer is D. Question 4. An atom with a nucleus containing Z plus N equals 31. That element is crucial for human cellular energy. What is the identity of this atom if N is equal to 16? Okay, we have another piece of information saying that Z is the number of protons and N is the number of neutrons. Remember, the identity of an element is based on the number of protons in the nucleus of that element. Since we have the value of N, we will put that value into the equation, and we get that Z plus 16 is equal to 31. And that gives us C, which is equal to 15 protons. So, looking at the periodic table, that element is phosphorus. Is phosphorus crucial for human cellular energy? Of course, yes. Phosphorus is a big part of adenosine triphosphate, an energy storage molecule found in all living organisms, including bacteria, fungi, and blue whales. Therefore, the answer is C. Let's move on to the next question. Question 5. The A, B, and C containers have different shapes and volumes, but hold the same pure water. The water height above point P of each container is 4 centimeters. Which container has the highest pressure at point P? Point P is right here at the base of all 3 containers. And the question asks which container has the highest pressure at this point. The hydrostatic pressure formula is this. As you can see, the pressure is proportional to the height of the water, the density, and the gravity. The hydrostatic pressure does not depend on the volume of the container. Since the statement says the containers have the same pure water, the density is the same. The height is 4 centimeters for all 3 containers, and the gravity is the same. The pressure is the same at point P for all 3 containers. And the answer is D. Question 6. Which of the following molecules is nonpolar? Let's see the overall charge distribution of each molecule. The sulfur dioxide structure is like this. The molecular geometry is bent, and the charge distribution is slightly negative on oxygen atoms and slightly positive on the sulfur atom. There is a net dipole moment towards the oxygens. Therefore, sulfur dioxide is polar. The carbon dioxide is linear in geometry. The dipole moment towards the oxygen atoms cancels out, and the overall net dipole is zero. Carbon dioxide is a nonpolar molecule. Ammonia is a polar molecule because the nitrogen atom is more electronegative than hydrogen atoms, creating a slightly negative charge on the nitrogen and a slightly positive charge on the hydrogen atoms, resulting in a polar molecule. Water molecule is bent in molecular geometry, and it has a net dipole towards the oxygen atom, making it a polar molecule. Among the four choices, only carbon dioxide is nonpolar, and the answer is B. Question 7. Which of the following gases will likely deviate from the ideal gas behavior at high pressure and low temperature? When considering ideal gas deviation, intermolecular forces play a significant factor. Let's go through the given molecules. Out of the four, the water has hydrogen bonding, which is a significant attractive force between water molecules. The answer is choice B. We have a passage here. Lenacapavir, with a molar mass of 968.28 grams per mole, is an anti-HIV drug that works as a viral capsid inhibitor. Lenacapavir molecule interferes with HIV capsid assembly, the viral core capsid nuclear uptake, and the virus replication process. For lenacapavir to be effective, a 927 milligrams subcutaneous injection should be taken. Lenacapavir's difluorobenzyl group docks deep into the hydrophobic pocket formed by two adjacent HIV capsid hexamer subunits, competing with and blocking NUP153 and CPSF6 host cell proteins, which help the virus enter the host cell nuclear pore. Lenacapavir establishes a network of hydrophobic and hydrogen bonding interactions with the amino acid side chains of the virus capsid proteins. Question 9. If 927 milligrams of lenacapavir is required every 6 months to inhibit the virus life cycle, how many moles of lenacapavir are needed? Okay, first, we need to know the mole formula. A mole equals the mass divided by the molar mass of the lenacapavir drug. We have the mass here and the molar mass right here. The mass is in milligrams, and we have to change it to grams. Therefore, mole equals 0.927 divided by 968.28. Going through the multiple choices, eliminate choice C and D because the numbers are big. B is the answer. Question 10. Lenacapavir inhibits NUP153 and CPSF6 proteins from binding to the HIV capsid. What type of inhibitor is lenacapavir? The second paragraph says difluorobenzyl group, which is number 3 on the diagram, docks deep into the hydrophobic pocket, competing and blocking the host proteins. That information tells us that lenacapavir is a competitive inhibitor, and the answer is A. Question 11. The difluorobenzyl group, marked number 3 on the diagram, docks into virus capsid protein hexamers. What type of intermolecular force is this interaction? The second paragraph says, the difluorobenzyl group docks into the hydrophobic pocket. And if you look at number 3, difluorobenzyl has a hydrophobic region. The answer is C. Question 12. Which of the following is an electron withdrawing group? Electron withdrawing usually happens when an atom pulls electron density towards itself through resonance or induction. Electron donating groups are atoms or groups with available lone electron pairs to donate. Let's go through the answers. The amine group choice A, the hydroxy group choice C, and the ester group choice D have available lone pairs and are electron-donating groups. The cyno group choice B is the electron-withdrawing group because it pulls electron density away. So, the answer is B. Let's go to question 13. By which method does the lenacapavir drug inhibit HIV? Choice A, Choice B, and Choice C have been mentioned in the first paragraph. Therefore, the answer is all of the above. Choice D. Question number 14. What is the most likely mode of inheritance? Okay, let's examine the pedigree diagram. First, we see the pattern of inheritance of the disorder. Look at generation 1. Individual 1 is the father, and 2 is the mother. Both are unaffected. For generation 2, only individual 3, who is a male, is affected. This tells us that the condition skips a generation, which means the trait is recessive. The second indication is that it only affects males, which means the trait is an X-linked condition. The answer is A. For X-linked recessive, when the genes on the X chromosome have mutations, males carrying this mutation would be affected because males have only one X. Females having one copy of the disorder become carriers, and this disorder affects males very often. Question 15. When calcium is released from the sarcoplasmic reticulum, it binds to which of the following? The sarcomere is a functional unit of muscle fibers responsible for muscle contraction or relaxation. All these four are in the sarcomere functional unit. Calcium is released from the sarcoplasmic reticulum and it binds to troponin C, causing a conformational change in troponin subunits, allowing tropomyosin to move away from the myosin binding site on actin. And the answer is C.